Hello, everyone. Thank you for joining us today for this SDT LinkedIn Live. We're super excited to have you here and to discuss with you some of the important concepts of ultrasound versus vibration analysis. Ultrasound's emergence as the go-to condition monitoring technology for reliability departments is owed to its simplicity, its versatility, its shallow competency curve, and its fast return on investment. But some organizations are uncertain where ultrasound fits in with their other condition monitoring technologies. And we're often asked, I already have vibration analysis. Why do I need ultrasound? To answer this very valid question, we've assembled a panel of ultrasound experts to share their point of view. First, we have Robert Dent, General Sales Manager of SDT Ultrasound Solutions. Rob's a multi-decade veteran supporting condition monitoring technologies for clients since the early 1990s. Adrian Messer brings almost 20 years of experience in ultrasound, supporting maintenance and reliability throughout the United States. And finally, we have Bob Lees, who's 40 plus years serving Canadian pulp and paper, manufacturing in British Columbia, more than qualifies him to weigh in on this panel. Gentlemen, welcome and thank you for joining us to address the question, I already have vibration, why do I need ultrasound? We've identified 6 talking points, so I want to start with the first one, simplicity. Ultrasound is well known and famous for being the simplistic, easy to use ultrasound technology. Rob, you kick things off. What do you have to say about simplicity?
And one of the key things about ultrasound, in my experience, coming predominantly from the vibration world and then moving into ultrasound, is the ability to match what you hear with what it is that you're actually inspecting. So, having that direct connection to the ultrasonic signal that's being generated is really a lights on moment, and it's quite exciting. When you get that first positive reaction of like, oh wow, that's a leak, or oh, I hear something bad with that bearing. So I think from that perspective, it's really quite easy to use. So.
Adrian, what would you add to that?
Yeah, certainly the learning curve is much shorter. And usually when we go in to provide support after someone purchases one of our devices, such as like an equipment orientation type support, typically just after that equipment orientation, that individual is going to be comfortable enough to where they can take that instrument and begin to go out and use the device. And from there, it's only going to get easier once they understand and learn what things should and should not sound like. And then the data that ultrasound provides certainly can back up those findings.
Bob, spending 4+ decades working inside of industry, you have a different perspective, I think, on how simplicity applies to condition monitoring technologies. What would you specifically say about simplicity around ultrasound?
I think one of the things with ultrasound is that it is really intuitive. You can pick up a device, whether you're skilled at ultrasound or condition monitoring or not. You can pick up a device, put a sensor on or use an airborne sensor, and immediately get feedback to the condition. If you hear basically white noise, then typically 90% of the time, 95% of the time, there's no issues with the bearing. But even an unskilled person can put the headphones on, take the device, put a sensor on, and hear the health of a bearing. And for people just coming into condition monitoring, or even for tradespeople looking for a leg up on could there be a problem with the asset, I think this is invaluable information.
Yeah, we hear the term ODR, operator driven reliability, and ODSR, operator driven safety and reliability, and I think that those two terms, whether you choose to use the one that involves safety or the one that just involves reliability, I think that those two terms are only made possible because of the simplicity. Would you agree?
Oh, 100%. It's again, as I said a moment ago, it's so intuitive to just put on the headphones, go and listen. And in operations, in production, in almost every facility I've been in, there is information that is required to the health of a bearing in an asset. And as you said, operator-driven reliability. Quite simple. Just take your headphones, your device, go down and listen to the bearing. If you hear something that sounds like impacting or rubbing, chances are there is something wrong with the asset. And that's going to further your investigation into it. If you're listening and all you're hearing is white noise, well, maybe you need to look at a production issue that's causing the problem as opposed to a mechanical issue that's causing the problem.
And I think to
Adrian,
add to that as well, sorry
no,
to
it's
jump
good.
in. How many times have you been sitting with the maintenance crew and one of the operators or production supervisors walks in and says, "Hey, here's something unusual coming from this machine. Can one of you vibe heads or ultrasound guys come out and inspect to see what's going on?" Well, putting this kind of equipment in the hands of the operator, they can identify problems a lot earlier on the P2F curve and be able to bring those questions to the techs a lot earlier than waiting for that squealing of whatever's going on where it's really audible. So I think there's some real benefit there.
Adrian, what would you say are the advantages of being able to put a tool that's known for simplicity into the hands of operators instead of trained condition monitoring technicians?
Yeah, certainly. And it's important to get that operator feedback because those are the people that live with the machine hours and hours each day. So if you have something that easy to use that you can put into their hands, if they sense that something doesn't just sound right, feel right, smell right, then they can become your first line of defense, if you will. They can pick up on those problems before they become major problems. Then you can plan and diagnose exactly when to make the change out or what to do next. So very important.
Yeah. What I love about everything that you guys are saying is that because we can now offer a tool, a technology with that level of simplicity, we're knocking down the walls between condition monitoring and the rest of the plant, and we're putting more boots on the ground. We're getting the informed opinion of people who are intimate with the asset. So definitely there's so many advantages to being able to implement these simple tools. Another word that we often see used to describe ultrasound is its versatility, and a lot of the marketing speak that you'll see if you're a follower of SDT ultrasound solutions is the word versatility and the 8 application pillars. And so Adrian, if you could just speak from your experience about the versatility of ultrasound as a condition monitoring technology.
Yeah, sure. Each one of the condition monitoring technologies have particular applications, and we'll find failure modes where they're very specialized, where they really tend to shine. But if you look at ultrasound as a whole, this is primarily a vibration focused panel, so we're talking about mechanical applications. But ultrasound can be used for more than just mechanical applications. I think your quickest return on investment application would be compressed air leak detection. We have had a lot of recent discussions about how to use ultrasound for electrical inspection due to some of the latest revisions in some of the electrical standards for maintenance and safety, like NFPA 70B. Mm-hmm. So, again, the same tool that you use for bearing inspections, for mechanical inspections, can be the same tool that you use for all of these other applications, like leak detection, like electrical inspection.
I agree totally with Adrian. This one device can be used in so many different applications. And what I typically tell people is, when you're purchasing ultrasound equipment, decide on what application you're going to implement it for. I often use the analogy that it's like Christmas morning for a child. When you buy an ultrasound device, there's so many things that you can use ultrasound for that it kind of gets lost in the mix, that you actually don't really start the program very well because it's so versatile. To go off what Adrian said, I recommend people pick a technology or pick an application and start using it there, become familiar with it, and then expand your program out, because at the end of the day, you'll be able to use ultrasound for all of the different applications that Adrian mentioned.
Robert, we're talking about we're answering a question. I have vibration. Why do I need ultrasound? So specifically in terms of versatility, because there is crossover between ultrasound and vibration for rotating assets. What would you say, or how would you speak to the versatility of ultrasound versus vibration, specifically in some of the rotating applications and the mechanical applications?
As much as anything, it is such a complementary technology to go along with vibration. So if you're already doing vibration, you get what you're there for. But when you add the versatility of ultrasound, and especially the ability to use the airborne side of things, listen to couplings, listen to belts, listen to chains, ultrasound being high frequency, short wavelength, you can put your contact sensor on each bearing housing and get an indicator of the friction or the impacting that's coming from each specific bearing. Vibration is a lot more holistic. You're looking at everything that's going on with that complete rotating asset, and then it's up to the analyst to try and determine, what's causing the problem and where it's coming from. With ultrasound, you can really pinpoint some problems very, very quickly. So I think it can be very beneficial to include ultrasound as part of your overall program.
Bob, when you were using ultrasound and vibration at Canfor Pulp and Paper, did you have specific examples, or can you recall any specific examples where the versatility of ultrasound just made more sense to pull that out of the toolbox?
Once we started with our ultrasound program, for me personally, as a vibration analyst, it brought together all of the aspects of the condition monitoring. So I could look at the time waveform and I could get good solid information out of it, and then I could look at the spectrum and get good solid information out of it. One of the things we learned very quickly was that by looking at the time waveform with the ultrasound, we could tell the difference between an impact or a rub. Often with our vibration analysis equipment, we would get a one-times impulse, one-times turning speed impulse, but we would not know exactly what it was. Whereas with ultrasound, we could look and see, yes, that is a one-times impact, or that is a one-time rub. So it allowed us to completely fill in the picture. Both technologies would tell us that there was an issue, but in many, many cases, ultrasound would tell us more information of what the issue was than what vibration would tell us.
Adrian, do you have anything to add?
Yeah, there is a lot of overlap, and I think not to get too technical, but sound at its source is a vibration. So we tend to see a lot of overlap, and also if you think about the P to F curve, this wouldn't be a reliability talk if we didn't talk about the P to F curve. But
Absolutely.
Any of the P to F curves will show that the first technology that will give you an indication of a potential problem is ultrasound. So because we're only measuring slight changes in sound or decibel level, we're really good at finding these problems early. And then the ability to be able to diagnose the problem early also just helps to determine what the next steps will be.
Yeah, so we've talked about, Bob, you mentioned the word rub, you mentioned the word impacting. We've talked about compressed air leaks and steam traps and valves and all of these different ways that we can employ the technology, which makes it so versatile. And it really, I think you can summarize the versatility by going back to what ultrasound actually measures, and that's friction, impacting, and turbulence. The first letters of those three words spell fit. And as condition monitoring technicians, you are all out there to create reliable assets, and reliable assets are assets that are fit. And I think if you just remember those three letters in that word, you'll always know where you can deploy ultrasound, whether it's for non-rotating assets or the rotating assets that you're already monitoring with vibration. Good. Bob, a few years ago, you and I had the privilege to be invited to the International Maintenance Conference, where we gave a 90-minute workshop on competency curves. And so without really injured, I'll just let you take that topic away, because I know that's, as a trainer of ultrasound technologies now and an implementer of ultrasound programs, it's one of the first things you speak to.
Yeah. So with ultrasound, one of the things that we've talked about it, Rob's talked about it, and Adrian have talked about it, is the ease of use, how intuitive it is, and how we can start very, very quickly making determinations on the health of an asset. Many industrial complexes have vibration analysis programs. What's going to happen in each one of those is there going to be a point when they're going to need to start replacing their employees through retirement or through internal movement. And what happens then is that they need to decide how long it's going to take to get this new condition monitoring person up to speed so that they can replace, so that they can be as fully competent as the person they're replacing. And the studies we did, we've determined that it's about 7 months to become fully competent as an ultrasound technician, whereas the 3 to 7 to 9 years to become a vibration analyst. So the competency curve for ultrasound is incredibly short. So the problem is that when you're transitioning through from an older condition monitoring technician to a younger one or a newer one, you lose some knowledge, you lose that expertise. And with idea with ultrasound is that in a matter of a few months, you can start making those high-level calls that would take a new vibration analyst, like I say, 3 to 5 to 7 years.
Yeah. Care to add something to that, Adrian?
Yeah, so one way that a lot of companies get around the competency or having the skilled people to do the vibration work is they contract it out. So they rely on the services of outside contractors to come in either quarterly or once a month to take those, what I guess I would say more advanced, vibration readings and vibration data. But a lot can change and a lot can happen in between the time when your service provider is going to come in. So one way that you can add coverage and be a little more comfortable in that is deploy ultrasound. Ultrasound is easy enough. The learning curve is much shorter. The investment in the technology and training is certainly more economical. So that way you have something in-house that you can use, especially on your more critical assets or even assets where your service provider is not collecting data. So that way you've added coverage. And again, you don't have to invest heavily in the technology and the software and the training to get one of your employees up to speed, up to that level of the where your service provider, may have that knowledge and expertise.
Yeah, I agree. Robert, you come from a vibration background. On our panel here, you probably have more vibration experience, having supported IRD, Comtest, Bentley, a number of different systems. So I'm pretty sure you have a strong opinion about the competency curves for ultrasound versus vibration, having been the newest member to the ultrasound world.
Yes, no, absolutely. Vibration, excellent technology. You get a lot of good results with it, but there is some complexity to it as well. I don't know how many times, you've walked into a machine shop and seen, vibration analysis wall chart, covering scads of space on the wall of all these squiggly lines, waveforms, and FFTs. And, as someone who's new to the technology, you kind of look and go, holy, wow, what does all that mean? Ultrasound doesn't have that complexity. So, you can take an ultrasound device and as Adrian and Bob have already mentioned, you can get some very, very good results very, very early. And that's going to breed confidence. And one of the things that is a problem with vibration is that it can take a good couple of years to get that confidence that the call you're going to make about the specific health of that asset is going to be accurate. And as a supplier of information, you need credibility. And when you make a couple of false calls, your credibility kind of is in the toilet. So having ultrasound as a technology that you can be very comfortable with, hey, there's a problem there, or that pipe is leaking, or whatever the case may be, is going to add to your credibility. It's going to build that confidence and allow you to kind of move forward with, the career you're looking for. So
yeah, what's worse, to know that there's a problem and not report it, or because out of fear of being wrong, or to report the problem they take it apart and find out that you were wrong, that there was nothing wrong with it. But I think, yeah, I think you always want to err on the side of caution. Bob, you've told stories to me countless times of when you were working still as a millwright and a condition monitoring technician back at Canfor, how your vibration analysis team could never really keep up with the demand, the number of assets. And so, you know, you're really just focused on A critical assets, and maybe they got around to B critical assets. And it always, to me, as somebody out on the outside looking in, I always thought to myself, why are these high level, you know, Cat 2 and Cat 3 and even Cat 4 guys running about the plant looking for problems? That's got to be something that can be farmed out to a competent person, a confident person with a technology that's quicker, easier, maybe a little bit less costly, so that these white glove experts could just focus on analyzing the problems that these guys found. And you've told me stories about that, where you used to follow around the vibe guys with your ultrasound.
Yeah, particularly on assets where you have a lot of energy being created by unbalance or by intentional vibration or even unintentional vibration. A lot of your readings, as Rob mentioned, can become very, very difficult to analyze, to read them, to determine what if there's an issue, first of all, and then what the issue is secondary. What we used to do, because we had part of our compliance issue or our compliance mandate, was that we would take vibration readings on all of the rolls on both the pulp machine and the paper machine. The only problem is that they tend to be out of balance slightly, or they tend to be coated in stock, which is pulp or paper. And all of the readings would become a little bit difficult to read. So what we would do is we would go out, we would take readings on all the 150 rolls, and then I would wander around immediately afterwards, within an hour afterwards, with the ultrasound device, and I would simply take a 2 or 3 second sample, which is extremely quick, and then I would tell the vibration analyst, okay, look at roll 62, there's a problem with that. Look at roll 58 on the paper machine, there's a problem with that. We wouldn't even analyze the vibration data anymore, because there was so much rotational energy in the readings that it made it extremely difficult to determine a bearing issue. But with the ultrasound, I just wander around, take a 3 second reading, and I was just going by what I heard. I wasn't even analyzing the data. I would let the condition monitoring technicians, I would let them dive into the vibration and to the ultrasound data. Just by listening to the roll bearing as I walked around, I was able to determine, you know, of the 150, there was only really 5 that we needed to dive deeply into.
Bob, what are your qualifications in vibration analysis?
A level 3 vibration analyst, and just a very quick comment about that. When I first became a vibration analyst, training was difficult to get, and the training was also tended to be incomplete. And so I struggled early on in my career as a vibration analyst. And then when ultrasound came along, and I was able to see a time waveform and to start understanding what a time waveform actually tells us compared to the disaster, to me, being an untrained vibration analyst, that a vibration time waveform, it allowed me to fill in a lot of the gaps in my learning about vibration analysis. I was able to use ultrasound to fill in those gaps and to explain it to a much better level to me, because everything is visual with ultrasound. When you take it in, dump it into your software, and you start analyzing the time waveform, so much information is present. So then what I could start doing is going, okay, this is why the vibration time waveform looks like this, because of what I can see in the ultrasound time waveform. To me, it was invaluable. As a condition monitoring person, ultrasound was invaluable to making me a competent vibration analyst.
So the next bullet point that we identified as a potent reason to add ultrasound to your vibration analysis dominant condition monitoring program was the ability to collect airborne data. And so we know that one of the limitations of vibration, by the very nature of its physics, is that in order to collect data, we have to contact the asset. We have to have some kind of a physical contact between the asset and the data collector. Going back to the word fit, friction, impacting, and turbulence, well, one of the key differences between ultrasound and vibration is that we're not measuring the physical movement of the asset. We're measuring the sound pressure or the ultrasound pressure waves at a microsonic level that are being produced by defects. And those are either manifested through friction, impacting, and turbulence. But because they're sound pressure waves, we can detect them with airborne sensors. Robert, I'd like you to speak because I know you've got so many examples and case studies on where the use of airborne ultrasound sensors has really enhanced the defect detection on rotating assets.
Yes, absolutely. And I'm going to give credit to Mr. Lees here, Bob. When I first was early in my career with SDT and the early days of ultrasound, as I was utilizing technology, Bob was talking to me about using airborne ultrasound for inspection of couplings. And I'd been at a couple of facilities with him and I'd listened to a couple of couplings, and I was blown away by the potential for using the technology for identifying problems with couplings. And if you think about, rotating asset, you have certain points of failure. So, we're always looking at bearings, we're always looking at seals. Couplings is another one of those weak points that has the potential to fail and cause a problem. And obviously will take the machine down very, very quickly. So once I got my head around using airborne inspection of couplings and understanding where friction, impacting, and turbulence fit into the failure modes or the failure patterns on couplings, it was like my eyes were so wide open at that point. I mean, even something as simple as like an Omega tire coupling, which, is designed to allow for a lot of misalignment, or to, limits the amount of, I can't think of the word I'm looking for, but it gives you more
torsional load.
Or you don't have to be quite as accurate in your when you align the machine. It gives you a little more flexibility. But when there's a small tear in that Omega tire coupling at the very earliest stages of it begin to fail, it will generate some turbulence, which is very easy to pick up with airborne ultrasound. And it doesn't even matter if the coupling is completely guarded out. There's always air gaps where you can get the airborne coupling in, point it up at the coupling, and be able to listen to what's being generated. So, white noise is a good healthy sound from a coupling. We don't really want to hear anything. As soon as we start to hear any kind of modulation, any kind of turbulence, any kind of friction or impacting, it's a very quick indicator that investigation is required the next time we're able to have that machine shut down. One of the biggest time sinks for mechanics can be doing a regular coupling inspection on a shutdown, where they spend hours taking things apart just to find out that there really wasn't a problem there. So when you can add this to your arsenal, it makes you a lot more effective. So,
yeah, Adrian, what say you?
Yeah, to Rob's point on the couplings, there's a lot of companies out there that do a lot of time-based repair, on couplings, so at certain timed intervals, they'll just go in and rebuild or replace the couplings. Well, they're doing a lot of unnecessary work because a lot of those couplings, there's no issues, no problems. So that's a great application where you can deploy airborne ultrasound, is with coupling inspections. Also, where I've seen a lot of successful use with airborne ultrasound for mechanical inspection is one with conveyors. Maybe you're in a mining industry where you've got thousands of feet of either rollers or some sort of open-faced rolling element type bearings. It would be impossible to go around and make contact with every single one of those. So a lot of successful use in airborne ultrasound, just simply either walking the line, or I've even seen where you just hop in a truck, hop in a golf cart, and just ride that conveyor line. And if you have one of those types of bearings going bad, it will give off airborne audible ultrasonic noise that you can then narrow down and pinpoint exactly which one of those is going bad. Also in distribution type centers, where again, you've got thousands of feet, if not miles, of conveyors. Just simply walking that conveyor line with, say, something like a Paradish or some sort of long range type attachment to where your distance is easily in excess of 90 to 100 feet. And even if that distance is very narrow in focus, so it makes it very easy to pinpoint which one of those rollers or which one of those bearings is going bad.
Hey, Bob, as one of our principal implementation trainers, could you speak to the specific characteristics of ultrasound versus sound or vibration that make airborne ultrasound? Because to me, if I'm using an airborne mic, I can visualize contacting an asset with a contact sensor and closing my ears off to the rest of the world. But if I'm walking through a plant that's very noisy with an airborne sensor, aren't I just going to pick up everything?
All of SDT's sensors work in a very limited bandwidth, 36 to 40,000 hertz. Typically, the audible sound that we hear created by almost everything in industry does not fall into that very narrow band, that very narrow frequency band. The only things in industry that create ultrasound in that frequency band are friction, impacting, and turbulence. So you can go, and we're talking about couplings now, and Adrian and Rob are talking about couplings. You can go into a very, very noisy environment, but most of that noise is audible. It is undetectable to the ultrasound sensors. So that'll allow you to go in and take your sensor and aim it at, say it's a chain drive. And you can listen to the chain drive where all of that, what we call noise pollution, the audible noise pollution, is not collected by our sensors because it's outside of the bandwidth that they collect at. And so I just wanted to talk very quickly while we're talking about airborne ultrasound. And one of the things that ultrasound has been known for decades has been leak detection. And one of the most cost savings determination of an air leak I've ever been involved with was on an airline that was about 1/4 of an inch in diameter. And what it was it was actuating a part of the process, was actuating a movement. And there was a tear in that very small line, which we back in the day would call an instrument airline. And it was torn, and it was not providing enough air power to actuate the device. And it caused 7 hours of downtime before we actually found it. Most of the time when we talk about air leaks and air leak detection, we're talking about the big supply airlines, and absolutely 100% we can help by using ultrasound and determine not only if there is a leak, but where the leak is. But like I say, one of the most cost-effective calls we ever made was on a 1/4 of an inch airline that was causing production to basically come to a complete halt.
Yeah. So you guys are talking couplings, you're talking omega couplings, grid couplings, flexible couplings, you're talking chain drives, maybe even some pulleys and belt sheaves. We're not talking about high stakes assets here. I mean, these are $30 parts sometimes you can pick up at the local farm equipment dealership. Why should we even be concerned about something that's so inexpensive and relatively easy to fix? And most of these components don't tend to fall under the regular PM maintenance. Like I don't know. I ask a lot of our clients, do you have written PMs to go out and maintain chain drives? And almost all of them say, they look at me like I'm from outer space. So what would you say to a potential client interested in implementing the airborne aspects of ultrasound for condition monitoring? And he said, well, these aren't expensive assets.
Well, I'll start. Okay, so it may be an inexpensive part, but it may be very critical to the process. Maybe it's some sort of a belt-driven fan that may, if it fails, may have some sort of safety or environmental consequences. So, yeah, the part may be insignificant, but the consequences could be more severe.
And it's the nature of the beast as well. I mean, some of these consumables, like I was saying before, bearings, seals, couplings, I mean, they're designed to fail. They're not designed to last forever. So you need to keep an eye on them, because it only takes one of those aspects to completely fail, and it's going to bring the whole asset to a grinding halt. So, if your business relies on, making X amount of widgets per hour, and you lose a coupling or a seal, which means that you can only make 50% of the widgets, then there's a significant aspect or a significant uh, issue that is going to be needs to be addressed. And I think worrying about the individual cost of the pod is really irrelevant. It's to do with understanding what can fail on an asset in general, and making sure that your PMs or the condition monitoring tasks that you're doing look at the asset holistically, and identify what actually you need to be looking for. So
Great answer. I think we beat airborne to death. Let's move on now. The next real bullet point I wanted to address, and we see so many case studies published in SDT's ultrasound LinkedIn page, and also in our Found with Sound LinkedIn newsletter, where we talk about slow speed applications. And to that point, I don't know that they're comparable or that they should be grouped in together, but since we're talking, I think we can use this segment to speak about slow speed bearings, and also more specifically that one application pillar of lubrication. I'd like you to start, Bob, because you're a Cat 3 Vibe qualified guy. Because when we post these case studies, we'll often see the Cat 3 and the Cat 4 guys making comments and saying, "Well, I can use vibration analysis to assess and analyze slow speed assets." What would you say in response to that?
I'm not going to. I would not argue with any of those higher level vibration analysts, and with the higher level vibration systems that they could do that. What we're talking about here is, I'm bringing a bunch of other conversations into this. We're talking about the average person, the average condition monitoring person, at their competency level, and then at the ease of use. Now, one of the applications I discuss often when I'm doing a training episode is had to diagnose a bearing on a slow speed asset. The asset was about 15 feet long with a bearing on each end, but on top of that asset was 3 chain drive units, a motor, a chain drive, and a reducer, and there was 3 of those. This entire piece of equipment was just shaking enormously when I got there. And so absolutely, you can use vibration analysis to do some slow speed analysis, but try to do slow speed analysis when there is inherent energy from chain drives, from reducers, from motors, from misalignment. And so what I was able to do was this piece of equipment was rotating at 9 revolutions per minute. I took a 20-second sample, a test sample, just to see if I could get good data. And in that 20-second sample, I was able to determine that it was a rolling element problem with that. Not saying that you could not do slow speed analysis with ultrasound, with vibration, but I defy anyone to try to do it on that asset in that particular location, and to make any kind of determination whatsoever.
Adrian, what would you add to that?
Yeah, certainly if you have the right data collector, the right accelerometer, the right software, and then the time, you can certainly do, slow speed analysis with vibration. But again, a lot of people don't have the right data collector, they don't have the right accelerometer, and they don't have the time that you need to go out and collect that good data. But with ultrasound, it is very quick and easy. Again, we think about a 1 RPM bearing. It's easily done with ultrasound. Now, with slow speed bearings, you do need to exercise a little bit of patience, because again, we need to collect at least 1 full rotation on our sound file if we're recording dynamic data, which I would highly suggest you do on slow speed. bearing analysis, because we do want to look at that in the time waveform. So again, those anomalies, any kind of indication of impacting or rubbing, will show up very nicely in the time waveform with ultrasound. So again, with ultrasound, it tends to be one of the areas in which we shine is with slow speed bearing inspection.
Now I've heard 1 RPM. I mean, 1 RPM, anything less than one full rotation of the shaft isn't going to give us sufficient data. Rob, would you say even 3, 4, 5 rotations would be better?
Yeah, absolutely. I mean, when we're looking for some kind of defect, we're looking for repetition. So to ensure that, you're able to see that repeating signal, you're going to want 3 to 5 revolutions of the shaft to ensure that, it is occurring every time the shaft rotates. But the other thing to bear in mind as well is that when you have something that is very slow speed, there's not a lot of energy being generated. So from a vibrational standpoint, there's really not a lot of vibration to see. So people will then rely on, some kind of high frequency enveloping, some kind of spike energy reading, that if it isn't set up exactly as it needs to be, it's very easy to miss those very, very small impacts. And quite often those impacts can be lost, down in the noise floor just because it's low energy. So I think expertise and experience play a part as well. If you don't know exactly what you're doing and what you need to look for and how to set up the vibration data collector properly to be able to identify that problem, very easy to miss it. Ultrasound doesn't have that complexity. So, we're just listening for the presence of some kind of ultrasonic noise. And doesn't matter how fast it's turning, you're still going to get that tick of metal to metal contact if you have some kind of bearing defect, for example. So, it really does encapsulate everything we've already been talking about when we talk about competency curves, and simplicity is the ability to deploy a technology that is going to just improve your ability and make things easier for you to, see the problems you're looking for.
Robert, you have a lot of experience supporting vibration data collectors from various manufacturers. If I've got a 1 RPM or even a 2 RPM bearing, and I want to get 5 to 10 rotations of that shaft or a rotation of that bearing, so I have a good data set, where do I need to set my acquisition time for my signal? If I'm using one of SDT's data collectors, like the 340, for example, versus a vibration data collector, and do most vibration data collectors have the ability to take a long enough sample?
That's a complicated question and somewhat of a complicated answer.
You're welcome.
Yeah, thanks very much. So, it comes down to focus on the low end of the spectrum. So we're looking for an event that's going to be happening at a low frequency. So in order to zoom in on that low frequency where we're looking for those impacts, we are going to need to set what we call our frequency max. So the maximum frequency of interest low enough with enough lines of resolution or enough resolution in the signal acquisition, to be able to split the individual frequencies apart. And this is getting like kind of a little bit technical at this point, but the ability to generate that kind of collection with the kind of resolution we need, you're going to be standing there for quite a while to collect the data you need to be able to pick it up if you can at all. So, you're going to need to probably spend some reasonable cash on a pretty sophisticated piece of equipment to be able to do that. And it's going to take you an excessive amount of time. So ultrasound, literally, we spend a lot of time in the time waveform, and it's a lot easier to set up and say, hey, just give me a 60-second time waveform or a 40-second time waveform, and let me see what we can hear, being generated ultrasonically from an impacting standpoint. So it can be a lot easier to do.
Adrian, the SDT 340 is a sub $20,000 investment data collector. what is the maximum acquisition time if I had something that was just moving at a snail's pace?
Yeah, we can go as long as 10 minutes if you have that time. But yeah, certainly if you want to collect that kind of data, we can go as long as 10 minutes.
Excellent, excellent. Okay, so I also grouped in lubrication with the slow speed topic, and I'm going to run it back to you, Bob, because I've sat through many of your one-day lubrication workshops, and you always seem to dedicate a segment of those workshops to the lubrication of slow speed bearings. So we know that ultrasound is the go-to technology for greasing bearings, right? But you also caution people on slow speed stuff.
Right. So, in order for us to use ultrasound to assist in lubricating bearings, we need to ensure that the bearing, the lubrication mechanism, leaves the churning phase, which is where where the lubrication system is volatile, where it's been disturbed, where it's been corrupted, if you will. And then when it starts to run better, when the grease has had a chance to get expelled from the raceway, we call that the bleeding phase, where the greasing mechanism now is supplying oil to the bearing. It's the oil that lubricates the bearing. It's not the thickener. One of the issues with slow speed bearings is that they tend never to leave the churning phase. So what does that mean to us? When a bearing is in the churning phase as part of the lubrication mechanism, it's considered to be high friction or higher friction. And then when it moves into the churning or into the bleeding phase a few seconds later, then the friction levels tend to drop down lower and sometimes substantially lower. When we're lubricating slow speed bearings, they tend never to leave the churning phase, so that there is no benefit to providing a minimal amount of lubrication added to the bearing. What I usually tell people is that you add more grease to a slow speed bearing because you're never going to find the optimal amount of grease. The more grease, probably the better in many applications. And when we do our training, we actually provide people with the information to determine exactly what would be considered slow speed for greasing, ultrasonic grease replenishment, what is slow speed, and what would be normal speed, where we would expect us to be able to notice a reduction in the friction levels when the bearing goes from the churning phase to the bleeding phase.
Very good. Adrian, Robert, you both have a lot of customers that you're directly supporting who are now using either the Lube Expert or the SDT 270 or 340 for ultrasound assisted, or I like to call it evidence-based lubrication needs, meaning that we're not just greasing bearings based on their condition, but we're greasing bearings based on the evidence that we can gather that suggests that lubrication interventions need to be done. What portion or what ratio of your customers that you support directly are utilizing ultrasound to lubricate slow speed bearings versus normal or even high speed bearings?
Go ahead, Adrian.
Yeah, that's a tough question.
You like how these questions are getting harder and harder as we go deeper and deeper?
Yeah, slow speed applications are very industry specific. So you tend to see a lot of it in, steel manufacturing, heavy industrial. You tend to see a lot of it in pulp and paper, which both of those industries would do very well in. And we, some of our key strategic accounts are in those industries. So I would say within those industries, the percentage is very high. Outside of that, probably not so much, because again, it is very application process specific for those types of extreme slow speed applications. It's a very political answer.
It was indeed. Rob, how's your politics this day?
Yeah, I mean, I agree with Adrian. I think a lot of it can be determined by the specific industry, but when we are providing training, as Bob was talking about, we are giving formulas and information on where you can't provide effective acoustic lubrication. But there's always going to be, an exception to the rule. But for the most part, if something is very big and very slow, you're probably not going to see a significant amount of frictional change when you add grease to it and be able to listen to it acoustically. So it really is about educating the customer, where they can and where they can't, or where it's going to be effective or not as effective, and letting them make the determination of how they want to grease those bearings. But from my experience, when you get into super low speed stuff, you just don't see a lot of changes acoustically when you're providing grease. There's just not enough energy, as Bob said, to get out of the churning phase. There's not enough centrifugal motion to actually push the thickener out of the raceway and just leave the oil there. So it's just one of those challenges that we have to live with. But as long as we understand it, then we can deal with it. So
good answers, all three of you. Thank you so much. Let's wrap this discussion up. It's been excellent so far, panelists. The last point that I want each of you to ring in on is ROI, return on investment. And Adrian, I know you're a numbers guy, you're a business guy, so I'm going to start with you. What would you say to a client who called up and put this question to you? I've already got vibration. I want to add ultrasound, but you tell me why I should add it, and how can I convince my management to spend the money? What's the return on investment of an ultrasound program?
Yeah, sure. So I mentioned earlier, the same device, like you can take an SDT 340 or a 270, and you can use it for all the applications. So I mentioned that earlier. So a lot of people will justify the cost of it just from simply compressed air leak detection. So they use, say, a 340 or a 270 in conjunction with our free download leak reporter app. Usually first time out of the box, you can find enough air leaks, or, if you're talking about specialty gases, like argon, nitrogen, oxygen, helium, very expensive gases, a lot of times one leak will more than pay for the cost of the tool. So that's just one way. Again, if you are relying on the services of an outside contractor where maybe you've lost confidence in that service and you're looking to kind of bring that in-house, again, minimal investment in technology, minimal investment in training, and you can have someone up and running. So again, that could be a way that you can easily have quick ROI from deployment of ultrasound technology. So there's lots of ways. Energy savings, ESG is typically, that's kind of the latest buzzword in the industry, environmental safety and governance. Yep. A lot of companies are paying attention to those types of metrics. So again, could be one way that you can budget for the technology, and then you can take that same technology, that same device, and now use it for a multitude of applications.
Robert Dent.
Allan Rienstra. Yeah, and we've touched on some of these points, but when we take into account, training, competency curves, the required expertise you need to be very effective with vibration analysis versus the results you can get very quickly with ultrasound. I mean, there's a much lower cost of entry into the ultrasonic world and being successful. So, and as a manager,
what is that range? What is that entry range? Sorry, I'm sure somebody's going to ask. So let's.
Sure. I mean, you can get into ultrasonics for as low as like $2,500 for something like an ultra checker, which gives you a device which you can pick up a whole bunch of different problems and be successful, whether it's looking for air leaks or listening to bearings or lubricating bearings. The same kind of price range will get you maybe an overall vibration pen, which isn't going to give you, anything specific. It might tell you about the general amount of overall vibration being generated by an asset, but it's taking into account that whole asset. So, okay, great. So, that vibration or that machine is vibrating at a certain level, but you don't know what's causing it. Or, and you need much more than that. So when you get into vibration, you could be spending, $60,000-$70,000 to get a sophisticated piece of equipment, plus the software, plus, yearly subscription fees to the software. And then you add training on top of that. And now you may have to wait 24 months before you've got someone who's confident and competent. Ultrasound, what, 270, 340, less than $20,000. Add some training on top, but the training required is significantly less. So just your cost for getting the program up and running is going to be significantly less.
Yeah. And Bob, we'll stop with you. We'll end with you. I ended with you on purpose because you come from the other side of the fence. You come from the user side of the fence, and so you've had to come to management and say, "I need ultrasound. I vibration analysis isn't enough. I need more." So how did you justify those requests when you were in industry?
Typically in industry, vibration analysis, condition monitoring personnel are 2 or 3 to a complex, and they have information, they have knowledge, and they generate reports. And the knowledge is not shared. The results are shared, but the knowledge isn't shared. And what I found with ultrasound was that I could go and hear a bearing that was a problem. I could then give my device to the supervisor and say, "You go listen to it." I could take the time waveform, export it out of the software. It's simply a wave file. I could send it to somebody and say, "Listen to this." When I'm not a salesperson, I don't know sales and I don't know the prices of things, and I specifically try not to know the prices of anything. I only recommend what I think is going to work. And so to me, return on investment is not how much money somebody is going to get back from making an investment on a piece of equipment. For me, return on investment is how much time is a person going to have to invest in something to make a determination or to make a repair or to make an estimate. So for me, return on investment for something like a loop checker or an ultra checker, which should be available at every tool crib in every facility in the world, so that somebody can come along, just take that simple little device, put the sensor on the bearing, listen to the bearing, and say, "Okay, yes, there's an issue here." That is a tremendous return on investment when the investment of that person may have been 5 minutes. And so I always look at it that way. How am I going to make my people more efficient? And ultrasound, hands down, is the best way when it comes to condition monitoring. In my regards, it's the very best way to get human return on investment.
Human return on investment. I like that. Yeah. We talk ROI, Adrian. We don't think about the human side of it. We're just thinking about the dollars and cents, right?
Yeah, that's a good point.
Yeah. Okay. So that's our question. I already have vibration. Why do I need ultrasound? And we addressed it with simplicity, versatility, the competency of our operators and our condition monitoring technicians, the ability to deploy ultrasound on airborne applications where vibration isn't necessarily a fit. Specifically looking at slow speed applications where we can have more people engaged with slow speed application assessments instead of having to always just rely on a Cat 3 or a Cat 4 who may or may not be on staff, and you may or may not have that $70,000 data collector in staff. And then finally, that return on investment. How many times I've seen and heard ultrasound salespeople say, "Oh, well, you get results right out of the box," or, it pays for itself the first time you use that. Or this device is going to pay for itself before this sales demonstration's even finished, and I have a time to write you a quote. I mean, those aren't just words, though. There is some truth to it. It makes me cringe when I hear it, but there is some truth to it, isn't there, boys?
Yeah.
Yeah,
really absolutely.
Yeah. I could go around the horn one more time if there's anything else that you would like to add to this before we wrap it up. Let's start with Adrian.
Yeah, sure. Whenever I'm having these types of discussions with people, and they will occasionally ask me which technology is better, ultrasound or vibration, my response is you got to go back to the failure modes. You got to understand the assets that you want to monitor. You need to understand how that equipment fails. And then that ultimately determines what technology you need to deploy that will find that failure mode at its earliest instance, whether that be ultrasound or vibration. But again, that's kind of my default is understand the failure modes of what you're looking for.
I love that answer. I love that answer because, you know, you make your living supporting ultrasound programs, and you know, people might just expect you to say ultrasound all the time, but the reality of it is that we need complementary technologies, not just one.
Right.
Like Harris Trebradovich is another guy in our, he has a wonderful presentation where he talks about your family doctor. And if you had a family doctor and the only instrument the guy had was an X-ray machine. So if you went in there with a broken bone, he took an X-ray. If you go in there with the flu, he took an X-ray. If you went in there with a hangnail, he took an X-ray. Well, you'd start to lose confidence in him after a little while. So I really like the authenticity of your answer. Bob, what about you?
Coming from the training side of this discussion, not that the other gentlemen aren't. To me, it's the simplicity of it. To me, it is the ability to listen while you're collecting a sample, dump the sample into your software, and then analyze the sample. To me, it is that simplicity. When I do training, after 24 hours of training, people are at the level where they can start making determinations on bearing issues and things like that. So for me, ultrasound is all about simplicity. We can do so much stuff with vibration analysis. Vibration analysis, we can do balancing. We can't do that with ultrasound. Should we not have vibration? No, we should have vibration analysis. It is definitely required in industry, but also bear in mind that ultrasound also has its place. And just going off of what Adrian said about the failure modes, I will often tell people that, if your main concern is bearing faults, then take ultrasound data. If you also have bearing faults along with unbalance issues, well, then take both. Take ultrasound for the unbalance issues, take vibration for the unbalance issues, take ultrasound for the bearing issues. You can carve out a very nice relationship between the two that is actually a time saving.
Oh, great advice. Great advice. Robert, last thoughts.
Yeah, now all the good points have been taken. You come to me. Thanks. Now, I think I'd sum it up by adding ultrasound to your program is just going to make you much more effective. And, you talked about the doctor and the X-ray machine. Well, the same thing goes with, you're tinkering around on your car or you're doing some repairs at home. You can't always use a hammer. You can't always use a screwdriver. You can't always use a saw. So you need to have as many arrows to your quiver as you can. The more tools you have, the better you're going to be. And, ultrasound has its place, vibration has its place, thermography, oil analysis, embrace them all, use them all. You just can have a much more effective program.
Yeah, well, you still found a pretty good point to wrap things up. I think that's the ultimate closing comment, Robert, is having that, embracing that entire basket of condition monitoring technologies. Yeah. Gentlemen, thank you to all of you. For sharing your time, first of all, also your industry expertise, your knowledge, and your genuine care for doing what SDT does best, which is to enable our customers to achieve their operational objectives by ensuring the reliability of their assets. There you have it. If you belong to one of those organizations with the mature vibration program and you're looking to see where ultrasound fits, you now have 6 compelling reasons to start a conversation or reach out to us at SDT and hear more about how we can help you implement this amazing technology into your condition monitoring routines. Everybody have a great and safe day, and thanks for joining in on this important webinar.